Hello, everyone. My name is Odysseus. I'm the CEO of phylax Systems. Today, we're going to talk about why audits are not enough. So the presentation has 3 points. One is why 2025 will be a watershed moment for security, why security is now moving away from being an afterthought and into the center of adoption. What are the shortcomings of the industry, and then how we can define a different protocol for hack prevention that actually works. So security in 2025. From 2019 approximately to 2025, we had what we call degen capital, right? We had all these inflows from people that wanted to take a lot of risk. In 2022, we were about $200 billion in crypto assets, but at the same time, we had about $3 billion lost only in 2022. And it's degen, right? And by degen capital, we mean people that are ready to take risk, right? They only care about maximizing the yield. They treat crypto as something that is inherently risky, and they really don't care if the UI or the dApps are experimental, if things sometimes break, if security is not top-notch as you would expect from cybersecurity best practices, is what we call the degen capital. But that's coming to an end, right? From this year and on, we're starting to see more and more institutional adoption as they're searching for higher and higher yields that the traditional financial system can support. And they're looking for something that they can't get from treasuries, right? The problem now is that right now the treasuries, for at least a 10-year United States Treasury is about 4%, which means that it's harder and harder every year for institutions to explain why they want to take this risk in DeFi when actually you can get pretty safe yield in the traditional system. And this type of user, this new user persona, is inherently risk averse. It's traditional institutions like BlackRock or banks, but also it's everyday people that will move from Web 2 to Web 3 to try new apps, to maybe save their livelihoods, right? And this new capital will be inherently more risk averse. They don't care about the highest yield per se. They care about the higher risk-adjusted yield, right? They want to take opportunities, but also manage the risk. Nevertheless, the market is exploding, right? We're seeing over 110 billion in stablecoins across all blockchains. We had this year about $3 trillion in transaction volume. And in 2024, we had about 44 billions of inflows, right? So market is exploding, degen capital is running out, a new kind of capital, more institutional, more risk averse, is joining. So the new entrants demand security. BlackRock launches a fund, which is called BUIDL, to start tokenizing assets, something that is also echoed by Joseph Pollack from Base, this new exploration into tokenizing assets onto blockchains. We see Kraken and Base launch superchain L2s, where not only they want to move a lot of their business from off-chain to on-chain, but if you see in both of these layer 2 messaging, security is a core part, right? The Kraken has talked a lot about sequencer-based security. Base is again and again saying that they want to create not only a new market for the global economy, but also something that is inherently safe. And why are these two players talking so much about security? Is because they understand what I said before, that the new entrants, other institutions or everyday people are risk averse, right? They can't live with the fact that they may lose their entirety of their capital just to get 20% yield. And it's interesting also that other ones, that Sui and Aptos, are also using security as a value proposition. For example, for the Move language, right? So we're seeing a move towards security not being something that only is concerned for auditors or builders, but it's becoming a core marketing position for these new networks. So what is the security flywheel? As we see more institution adoption, we see more inflows, right? More capital flowing into the system, into the crypto system. More inflows means that not only we have more users onboarding, but also crypto is moving away from the twilight and it's coming to the center of attention, right? There is more trust. So trust plus security practices, best practices, means that builders can experiment more. They can move away from using the same for code bases, the same mechanism, and they can start experimenting more because now they have users, and if they have also more security, they feel they can experiment without feeling that their career will be over. Also, trust and security improve the self-regulation of the space, right? This is something very important. There is a huge discussion right now happening in the space about all the grifts and scams that exist, and self-regulation is something very important. It's critical that we, as an industry, we can self-regulate, we can show that we can actually apply best practices in security, because if we don't, then we will be regulated violently and unilaterally. And finally, more security means that we have fewer black swan events, right? The Bybit hack, for example, where $1.5 billion were evaporated, is a black swan. And the industry will not be able to take a lot of this. So more security means that we have fewer and fewer of these incidents. So I hope I impressed the importance of security and why it's something that not only us as builders and developers, but also institutions understand. Let's talk about the current situation in security. So in general, we like to say that security has layers, right? It's the Swiss cheese model, or you can think of it like a castle with multiple layers of defenses. We have, of course, the tests where the developers are responsible for writing. They come in many flavors. Then we have something we call formal verification, where we can formally prove in a mathematic way that the code is secure. Audits, and finally, monitoring and incident response, right? What happens when there is a security incident, and how does your team respond to that? It's not enough. The tests are static. You write them once, and then you have to periodically update them, and they are imperfect, right? Developers forget test cases all the time because it's very hard to find all the edge cases into how your dApp might enter into an incorrect state. Formal verification is limited because if the protocol is too big, it's very hard to do, and also it's hard to do. It's something that requires a lot of development effort, which hardly seems a lot of times important versus futures. Then we have audits, which are expensive. This is the running joke of our industry, where protocols pay like $500,000 per year for audits, and also they are periodic, right? You do an audit here, an audit there. But in the meantime, you might deploy small improvements in your code, which you think it's safe, but a lot of times these create vulnerabilities. And finally, monitoring and instant response, it's too late. One of the core value propositions of blockchains is the immutability, right? When something happens, when a transaction goes on the network, it's done. So monitoring and instant response comes from Web 2. It's useful to know, but in crypto, there's nothing you can do about it, right? You just see your house being burned. So let's imagine a future where the base layer is actually incentivized to stop hacks before they are realized, right? Let's try to imagine how we could have this feature. And to do that, we have to answer these three questions. First, how do we define a hack? What is a hack? Which is also different for every dApp. How can the base layer prevent it, right? So we define the hack, how can the base layer prevent it? And then finally, we know what the hack is. We found a way for the base layer to prevent it. How do we incentivize the base layer, the network nodes, to actually do it, right? Because It's a network. You can't force them to do it. So this is the core pillars of what we're building at phylax. And basically, we try to answer these three questions. How do we define a hack? Let's say that you can define a hack in EVM bytecode, right, in Solidity. And you say that I define an invariant, a security rule. And if this thing reverts, then the state transition is malicious. The transaction is not right. So now that we have defined the hack, then we have to find a way for the base layer to commit to enforce it. So what do? We take this definition and we put it on chain. And then the base layer only needs to fetch that definition while it's building the block and say, I will not allow any transaction to go into the network which violates this definition. And because this definition has come from the dApp itself, it remains credibly neutral, right? The base layer doesn't make any decisions. They just respect the wishes of the dApp. And finally, how do we incentivize the base layer? It's very simple. Since we have all these things on chain, we can create a mechanism. And we can say that I will pay you fees to, as a dApp, I will pay fees to the network node, let's say the sequencer, to prevent the hacks. And if you don't do it, I'll slash you, or I'll just use a TE. So these are the three building blocks of what we're building. First, we define the hack as in Solidity, then we put it on chain, and the base layer, the sequencer runs a sidecar to fetch the definition and continuously check that new transaction doesn't violate the definition. And finally, the dApps pay the sequencer some extra fees for providing that service. This is an example of a hack definition, or an assertion as we call it. This is from the Euler hack. And here, it's actually very interesting because this EVM bytecode, this Solidity, is executed off-chain during block production. We can actually do a lot of interesting things. For example, here, what we say is we want to take the state before the state transition, and then we want to verify some invariant, right? We want to make a check. And this is a simple invariant, right? In another more complicated, we could also say, take the state before the state transition, the transaction, do something, and then take the state after the state transition, after the transaction, and do something else. And if this whole computation reverts, that means the transaction no longer should not be included in the block. And since we're using Solidity, it's very simple for developers to write it. Since we're using cheat codes to add new functionality, this reminds a lot Foundry, the testing framework, so it's easy for developers to be onboarded. This is an example of what assertions are. So assertions are this Solidity bytecode, and they have two interesting properties. They're atomic, right? They either are true or false, and they read only the state, right? They don't do anything on the state. They are read only, which means that, for example, this transaction calls three contracts. There are two groups of assertions for contract 1 and contract 2. And then what we do is, after the state transition, after the transaction is applied to the state, we can also run the relevant assertions. And because they are atomic and read-only, they can be run in parallel, right? So what we're doing effectively is we're upgrading the state transition function, and we add some functionality, something very specific that, because of its nature, we can parallelize very aggressively, and this becomes very fast. Which is why also these assertions are better to be defined in this specific format than be added directly to the smart contract code. Not only we can do more things, but we can do them much faster. So the first integration, we're integrated with the OP stack because it's very simple. And we're using Rollaboost, which is a component that allows an OP stack sequencer to have an external block builder. And what we've built basically is this external block builder, which behaves exactly the same as the reference implementation, but also during block production, it will fetch the relevant assertions, and it will check that every transaction doesn't violate them, right? And it's actually very important that we're using Rolla Boost from Flashbots, because in this way, it's not only easy for networks to integrate, but also we are superchain compliant, right? We work on top of the OP stack. And this is something very important because we don't want to violate the underlying protocol. We want to add some new functionality. So what's the conclusion for this presentation? Very quickly. One, security will play a central role. Onwards, it will stop being something that is only relevant for security engineers or builders, but will be relevant for everyone as we onboard this new type of users. It needs to be preventative, and also it needs to be dynamic. Audits are not enough. This periodic check of the environments is not enough. We can build new solutions that almost upgrade the underlying protocol, like Lido, for example, or phylax. Why Lido exists? It exists because, for whatever reason, the Ethereum protocol doesn't offer native restaking, native delegated stake, right? In the same way, the phylax tradable layer gives this new functionality to the underlying protocol. It enables the protocol to check for invariants which are defined by the dApps themselves, by builders, right? Why this is not part of the protocol? For reasons. Because the protocol can't evolve and shouldn't evolve fast. We can have also very powerful preventative solutions by building a mechanism without needing invasive SaaS solutions or AI black boxes. And finally, we can make security intuitive by reusing the mental models that people know. And this last part is very important because security needs to be intuitive not only for the people who consume it, like the end users who want to understand what the security properties of the dApp they will use, but also for the builders that will have to use the security tooling, right? If we force them to use some very complicated new language or new frameworks, they wouldn't adopt it. But by reusing the mental models they have, and this is generally a very good product philosophy, you can build new concepts, you can build new tools, new functionality with a minimum amount of onboarding difficulty. And this is, for example, the MVP of the UI, where anyone can observe the project, a contract, and then the relevant assertions, right? Which is very important to keep this protocol neutral. Users can inspect what invariants have been added to a protocol, not only to know the expected behavior, but also so they can know that they don't have to trust the dApp for doing the best practices in terms of security, but instead they can verify themselves. So let's solve security so crypto can win, because that's the important part. At the end of the day, it's not about building interesting security tooling. It's about making crypto win. Thank you.